Hi, this video will give you a demo to the new Drillsoft PMCD software. The user interface is the same as the Drillsoft HDX and HDX Plus, with some added features such as allowing for loss of circulation, total loss of circulation, bullheading, reverse circulation, flow control with added features such as controlling fracture severity, gas migration rates, and loss zone locations. As you can see in the well diagram on the left-hand side, we've indicated 3 loss of circulation zones due to fractures. On the left-hand side, we've added a PMCD sidebar to control bullheading, determine what kind of light annular mud to pump, to indicate fracture severity factor, allow for flow control to bullhead the gas back into the reservoir, control gas migration rate, gas percentage rate, and to keep track of total volume of mud or light annular mud bullheaded into the well. These features will allow you to successfully plan and schedule a PMCD operation and to allow to optimize the necessary volumes and rates to pump the LAM fluid and seawater into the well. We have also added a gas migration rate and gas influx location to the whole cleaning graph. Let's start the simulation by indicating 300 gallons per minute flow in and flow out. As you can see, our graphs are the same as the HDX and HDX Plus. We also have our temperature profile, our ECD, our pressure, and our trends. Now we can also indicate our pore and fracture pressure gradients and demonstrate them more clearly. All right. Next, as you see, we've indicated loss zones along our wellbore. This is the PMCD software functionality right here. This can be done in the Configurations tab under Trajectory and Formations. If you go down in the Formations, you can choose which zone you want to have the loss of circulation at. In this case, we've indicated 2,600 feet as a loss zone, which is a 200-foot thick zone. And then we've also indicated 3,200 feet, which is also 200 feet thick. And we've indicated 4,000 feet. The lowest fracture is at 4,000 feet to 4,200 feet. And this will allow us to have these red lines and also demonstrate the loss of circulation. In the Preferences tab, we can also keep track of other trends, such as volume reversed into the well. We can enable this, and we can also add the flow reversed. This will give us flow rate. So let's begin. In this simulation, we'll begin with drilling, circulating, making connections. So here we'll indicate 60 revolutions per minute and drill at 20 feet per hour. And we can begin our simulation. As you can see, we have our temperature profile, we have our hole cleaning profile. Since we're drilling, we're also picking up cuttings, and this graph demonstrates our cuttings percentage and our whole cleaning process. And we can also observe our trends graph to keep track of what's going on. So in this case, to go into the PMCD process, we can apply a wellhead pressure, a back pressure, and we can say maybe 200 psi. And with that, our wellhead pressure has created enough hydrostatic pressure in our upper and lower fracture that we are losing our drilling mud. As you can see in the flow out, our flow in, we're circulating at 300 gallons per minute, but we're only receiving mud back at almost 200 gallons per minute. And let's see what happened with our ECD. As you see, our ECD graph has exceeded our fracture pressure gradient. And this is a problem. As you can see, we've exceeded our fracture pressure, the pressure graph as well. So we can continue observing this, but we can also begin the process of circulating seawater to conserve our expensive mud. So we begin flowing seawater through our drill pipe. As you can see, the processes start pretty fast. This is rapidly changing our drill pipe pressure. We can see our standpipe pressure go up to maintain that 200 psi wellhead pressure. Our ECD is coming down. And we can keep track of everything that's going on in the hole by looking at the trends. We can keep track of where our fluids are by looking at the track volume tab. We can track our fluid 1. The drill string, we've only got 12 barrels left. And in the annulus, we have quite a bit of mud. We have over 460 barrels of mud. And our seawater has reached the bottom of the well and now is being circulated up the annulus. And we can also watch the ECD in the annulus go down as the seawater is circulated up and the heavier mud is removed from the well. We can begin, since our ECD is about to go below the pore pressure in order not to take a kick, we can start pumping in lamb uphill from surface into the annulus. And we begin bullheading. And we do this by turning on flow control setting flow out to 0, and then now we're pumping lamb into our wellbore at 300 gallons per minute. Our light annular mud weight is 11 pounds per gallon, while our seawater is 8.34, and our primary initial drilling mud was 12 pounds per gallon. We can get a better understanding of our fluid properties in the configurations option under the fluids tab. These can all be changed and updated as the process continues. As you can see, we're circulating back into the well. We can also see our annular velocity, and since we're pumping in reverse, we have a negative velocity profile, this blue line up here. And as you see, this value changes wherever we've set a casing. A smaller hole diameter provides a little greater velocity profile. And this becomes important during coal cleaning, or when we're trying to bullhead a gas bubble back into the reservoir or into a lower section in the well. We can again keep track of where our muds are, so we can go and see where the lamb is. We've already pumped in 79 barrels, and the bottom is at about 280 feet. We can speed up the process. In the Trends tab, we can also see how much and what rate of bullheading we've done, and go into a 2-hour time span. And the black line here at the bottom is our flow reversed, and the purple one is our volume reversed, the light purple. Let's change these colors to get a better understanding. I'm going to change this to, yes, better. There, let's do a green. And increase the size. Apply, and then volume reversed. You can change the color for this one too. Make it something like orange. We have an orange one. Yes, we do. Let's do yellow. And also increase the size and apply changes. So we can observe our values easier. So the volume reversed graph will show a total volume. so it will be a constantly increasing value. And the flow reversed is a flow rate, and it indicates the flow rate for the bullheading of the lamb fluid into the well, into the annulus. The purpose here is to replace the annular fluid with our light annular mud. We can turn on gas migration and allow for gas to enter the well. We've indicated gas migration rate at 1,000 feet per hour and a 7% gas concentration. We can also track the top of the gas, which is at about 3,178 feet, and we can observe our gas bubble in yellow on all four of the initial graphs we have here. But the whole cleaning graph also has the function of showing the gas rise velocity, and we can mirror this so that we can keep track of the difference between the gas rise velocity and the velocity profile of the bullheading. This way we can see at what part of the well our bullheading is more efficient. So our gas bubble is rising. It's at about 3,000 feet now, 3,080 feet. We can also pump through our booster pump as well. As you see, now that the annular profile, the cross-sectional area has gotten smaller, the mud is being bullheaded faster. The velocity is higher, so the mud is traveling down faster. So we can turn off our booster pump. Now that the lamb fluid has reached the lower fracture, we can begin working on our PMCD operation. In total, we have pumped in 435 barrels of lime into the annulus, and we've eliminated all of the original mud from the annulus and the well. So now we can begin looking at our trends. We can look for a stable wellhead pressure, which is indicated in the black line, and that is, so far we have a fairly stable wellhead pressure. So we can begin drilling the well, and we can do this by helping out with our hole cleaning process and turning from bullheading into zero flow out. This will increase our back pressure, so we can lower our back pressure and allow for full returns. We must observe the gas bubble location, our wellhead pressure, as you see, we have a gas migration occurring. The gas bubble is at 2,468 feet now, the top of the gas bubble. And we also have an alarm that indicates that the gas bubble is rising. Another way of tracking gas migration would be observing the wellhead pressure. Since we have constant flow rate, flow in and flow out, by looking at wellhead pressure, we can determine that the gas bubble is rising. In the trends, we can also see that the wellhead pressure is rising. We can change the color again. And we can also place these trackers to see what the pressures are at certain zones. So at this fracture zone, our ACD is 13.31. Now that the gas bubble has reached 2,200 feet, we can begin another cycle of bullheading. We are, as you can see, we're also still drilling at 20 feet per hour. So in order to begin bullheading process, we can drop flow out to 0 and then take it to negative and begin bullheading at 150. As you can see, the gas bubble is being sent back down hole, and this is slowly reducing our wellhead pressure. We can continue to keep track of the total reversed volume, and we can produce a report of how much drilling mud has been pumped in. We can obtain many different reports for this process, which will also help understand what rates we need to pump our mud in for the bullheading process. As you can see in the bottom left hand side, we have a status update, and we're reversing the flow, and we're also bullheading the gas. However, whenever there's gas migration, this will show up as an alarm indicating that gas is migrating or there's something else going on in the well. So it is a useful tool to be observing. We can produce those reports by hitting the record button here and recording the volumes that are being pumped. We can slowly ramp down our flow out pump to 100, and then to 50, and there's 20, and wait for the wellhead pressure to stabilize. that we've reached stability with the wellhead pressure, we can begin another cycle of drilling. And this will suddenly raise the wellhead pressure. And that is the end of our simulation. Thank you for watching.